So today I have a Chevrolet 350 block, casting number 1401-0207, 4-bolt main, mounted up on my boring and milling machine here. And the problem, it has one head bolt hole here that is all messed up. And that may not show to you folks as well as it does here, but somebody had put a helicoil in there. They did a very poor installation. I pulled the coil out of there, saw what a mess it was, talked to the customer about what do we do with this thing, and we determined that due to the cost of repairing this and possibly being a questionable repair when we did get done. See, I dropped my bolt. Where did that go to? Give me a second here. I don't know why that is, but anytime you drop something like this bolt, it will roll back to the exact geometric center of the workbench where you can't reach. So anyway, we've got the bolt here again. I didn't realize this, but helicoil threads are evidently the same diameter and thread pitch as chamferings, because once we pulled the helicoil out of this and saw what a mess the hole is, and now going back to work on it, a chamfering will screw in there. Doesn't fit very well, but it does actually screw in. I'm going to screw a bolt down in that just to show you what this thing is like. So I've got a square here, and I can line that up on one side here, and you can see, looking at the gap, it's pretty straight that way. Not really an issue. But now when I go this direction, you can see what a huge gap I have between the bolt and my square down here at the bottom, and I'm actually touching up here at the top. When you stand back and look at this, let me bring this in. I don't know if that'll show on the camera here, but you can visibly see that stud leans to the left. That's not going to be acceptable for holding a head bolt, holding the head down, keeping a gasket sealed, and also with that at an angle like that, it's going to put a bunch of stress in this area and probably really distort that cylinder. So anyway, obviously we can't even repair this with that size of chamfering because this hole is egg-shaped here, leaves a big gap on one side. So I'm going to go in with this and attempt to put what's called a Big-sert in there. It's an oversized chamfering. So let me back up here a little bit and get set up, and I'll show you what we're going to do. We need to be able to drill and tap this perpendicular to the deck surface. Best way to do it is right here in the boring mill. So I've placed my dowel pins back in the block here that I initially had out. I'm going to put a MLS head gasket over the dowels so it lines up on the block as it should be, and use the hole in there for my guide for what I'm doing. I happen to have a transfer punch here that is just about exactly the right size to match the opening in the gasket. I'm going to put that here in the drill chuck, and then I can move my block in the X and Y axis until I get centered up on this punch coming out of here. Now, I've already done that off camera, but I'm just going to show you as I come down on that into that hole. And let's bring this in a little closer so you can see what I'm talking about. Okay, you should be able to see here that I am just about perfectly lined up with the existing hole in that gasket. So I know I have my block positioned X and Y centered with the spindle here, so we can drill that hole where it really should be instead of where the last guy put it in. I'm assuming they probably did that by hand, maybe even in the vehicle, and if they did, I gotta give them credit. They did a pretty good job of getting that drilled as straight as they did, but it's not straight enough. So at this point, I'm going to take the gasket back off, take my punch out, and I'm going to use an end mill to bore that out. The drill that you're supposed to use with the Time-sert or with the Big-sert is 37/64, which is 1/64 of an inch larger than a 9/16 end mill. And I think by using an end mill, we'll be more likely to correct that hole than if we were to just use the drill bit alone. So let's go through with the end mill first. That'll get it within 1/64 of an inch of where it needs to be, and then we'll come back with the drill and finish the hole. And let's come down there a little bit closer. Let's run that probably about 500 RPM, and we'll just hand feed this down, see how things go. Take a little look at what we have that we're working with here. There, hopefully you can see it, how far off the hole was that the last person put in there. My end mill is cutting quite a bit over on the left side there and not even really touching on the right hand side where the threads are in there. So we'll go ahead and proceed on down through there and see how things go. I'm still not convinced we can save this block, but no way of knowing without trying.
You guys are all witness to the number of hours that we spend here in the machine shop standing on the hard concrete running these machines. There's really not a single machine in this shop that you can easily sit down at while you're operating it. We do try to put some cushioning down in front of the machines that you're standing in front of for hours on end. But even with that said, the only thing that really makes it manageable is the right footwear. And that's why my dad and I both have been rocking the most comfortable boots on the market from the sponsor of today's video, Brunt. I've been wearing the Omens for about a year now, I think, and I decided to get myself a pair of the black Omens just to maybe hide some of that grease and oil that we get into when we're doing teardowns. I really don't find myself needing toe protection in a pair of boots, nor do I need full-on waterproof boots, but the Omens are water resistant, which is nice because we do get into a little bit of water when we're cleaning parts off in the spray cabinet. Brunt also offers options that are full waterproof and composite toe, so they have options if you're in a trade where those things are more important to you. They don't just sell boots. These are some work pants that I've been wearing from them. Super comfy, super durable. I need to get a few more pairs of them for here in the shop with the winter months coming up. Now, the cleaning guy has been abusing his Omens in the shop, in the field, and around town for about the last year. So we actually picked him up a pair of the vast binders, and he's actually out farming getting one of his winter crops in, so I think we should take these by and see what he thinks. Brunt is so confident that they'll let you try any of their gear on the job, in the field, and if you don't love it, send it back. You know what you're doing?
Well, if I did, I wouldn't be running out of seed.
What do you think of these?
Those are pretty nice, except why'd you get my nice boots all dusty and dirty?
Oh, you were going to keep those as nice ones?
I was going to keep these for my Sunday go-to-meeting boots.
What about your Sunday planting triticale boots?
I hope I'm done by Sunday.
I just thought maybe you needed a replacement for your beat-up old ones.
No, these are doing just fine.
Well, there you have it. Cleaning guy wants to keep wearing the ones that he's been wearing out in the farm all summer long, as well as here in the shop. And he's kind of mad at me that I even got a little bit of dust on these ones because he was going to keep those for his Sunday best. So if you're looking for the best value on the market in a new pair of comfortable boots, check out Brunt Workwear. Get $10 off your first purchase today by going to bruntworkwear.com/JAMS. That's the initials for Jim's Automotive Machine Shop. That's bruntworkwear.com/JAMS and use code JAMS or click the link in the description. Thank you to Brunt Workwear for sponsoring today's video.
Generally, Cast iron is machined dry, but a little bit of lubrication does sometimes help. Makes it cut a little easier. So we'll put a little cutting fluid on there. I zeroed my DRO when we started on this just to see how deep we would go here. And at that point right there, I am better than 550 thousandths into the hole. And it sounds like it has virtually quit cutting anything. But I'm going to go on down here quite a ways so that when we're tapping, we don't have issues with the tap hitting anything down in the bottom. I think I'll stop at the 1 inch mark. Okay, there is 1 inch into the block. That is one big hole. Yeah, rather large hole in the block. The problem is, it was so far, not what I'm doing, but the last person that put that bolt hole in was so far off center that it still did not clean on the cylinder side. Cleaned everywhere else. Yeah, there's still threads from the last operation on that side there. So let's switch to the drill and we'll go one size larger. This is now the 37/64 drill bit that is included with the kit for these Big-serts we're using. I think I'll run it probably about 400 RPM here. Again, I'm going to put a little bit of lubrication on there, make it go just a little easier. And we will hand feed this down. Once it starts cutting, which is right there, I'm going to zero my DRO so I can go down at least an inch, just like I did with the end mill. Okay, there's 1/4 of an inch. There's 1/2 an inch. That's about the thickness of the deck on this block. What I'm cutting now at this point is just kind of following down the side of the cylinder wall. There's 3/4 of an inch. There's an inch. Just for good measure, I'm going to go a little further. There's 1.25 inches. So let's come up out of there and see what it looks like this time. You can see on the cylinder side here, there are still thread marks in there, but we have been clipping the top of them off. So I think we'll just go ahead and tap our threads in there, see what it looks like at that point. So let me switch tools and we'll be right back. There is one more step I need to do here before we actually tap the threads, and that's run the Big-sert counterbore tool down in. This cuts a very slight counterbore in the top edge there because this insert is not threaded all the way to the top. And I'm not going to counterbore this as deep as I recommend because you actually run it down till it touches on this surface here and stops cutting. I only want to go about half that distance because when I put this in, I want to be able to machine the block and have the top of this insert be perfectly flush with the top of the block. I do not want it recessed whatsoever. Okay, so let's install the counterbore tool. Put just a little lubrication on it again. Okay, there I just touched off. And I think if we go down, I'm going to say 45 thousandths, and we'll see what it looks like. Maybe I'll go 30 to begin with, check it again. Yeah, let's go with the 15 more. Stop at 45. Yeah, I like that. Or do I like that? Let's see how the insert looks in there. I'm going to go 15 more. Okay, there's where we left off. 15 thousandths more will make that 60 thousandths deep. And there we have it. So now looking at that with an insert, it appears to me that it will probably stop maybe just a little bit proud, and that's okay because then I can machine it off and have it flush with the top of the block. All right, let's move on. So now we're up to the tricky part of this repair. I need to tap the threads down in there, but I have to keep this tap absolutely perpendicular to the block surface. My tap handle is too small to fit this tap, so I can't use a tap handle for this operation. I can't chuck it into the machine and use the machine to tap because this machine does not have a hand feed that will follow the tap as it feeds down. The machine is completely geared to where as I crank it down, it goes a specific amount. It does not follow the thread pitch here. So what I'm going to do is put a center on the end of this tap to hold it straight up and down using one of these transfer punches. Maybe not exactly the right tool, but they seem to work pretty well for what I'm doing here. So I can set my tap down in there and I can hand feed the machine down until the point of that transfer punch is in the center of the end of that tap. And see, as I bring that down, you know, right now I can still move that around a little bit, but as I bring the drill chuck down, I eventually get to the point that almost all the play is taken out of that. So with that, then I can use a wrench here and turn my tap while I hand feed the drill chuck down to keep just a little bit of pressure against that at all times to keep it straight up and down. So let's get things lubricated here and see if we can make this happen. So I'm going to go about a quarter of a turn there and feed this down just a little. Quarter turn. Feed it down. Another quarter. Feed it down. It's hard to tell just exactly where I'm at. So I don't want to put a bunch of pressure on the tap, pushing it into the block, but I don't want to not have enough pressure on the top here to keep it perfectly centered. There, now we're down in enough. We're started to where when I come down with the drill chuck, I can feel it touch off on the top of that tap. Let's put a little lubrication on it again. It's going real easy at this point. I'm pretty sure I have come through the deck surface, and just like with the drills, it's just kind of going down the side of the cylinder wall there. Okay, I would say we're definitely far enough. So let's come up out of there. I really don't think you could have asked for that to work much better than how that went for us. And I think we cleaned up sufficiently well. You can see our threads that we have cut in there. And on that side over there, where the last guy had cut in, kind of actually a little bit into the outside side of the cylinder wall, it has cleaned up at this point. There may be just a little shadow there of the old threads, but I think things are looking fine. So let's prepare our Big-sert screw in there and see if we can get it installed. I want to coat the inside of our threads with Loctite. Make sure there's plenty on there. I'm almost out. Bottle is getting rather empty. I will also coat the outside of the insert itself. We'll start it down in. And then the installation tool looks a lot like a tap, but there's no flutes really. And it is to have a lot of lubrication on it when it goes through, because it actually swedges the insert into the opening. Okay, there, it's pretty much bottomed out. We'll put our tap tool on here and run this through, and that finishes tightening the insert into the block. And then you can feel it swedging that insert tight to lock it in there along with the Loctite. Once it's in, you can back the tool back out. I'm going to run it a second time just for good measure. There we have it. Now the test is if our hole is any straighter than it was before we started. So I'm going to screw that same stud back in here, and let's put the square up against this and see how things look. So before we started, that stud was especially leaning out towards the outside in that direction, and we've definitely corrected that, and it's hard to get the square up there where you can get a good visual on it, but I think we are still square in the front to back direction also. Okay, now that I have, I believe, successfully repaired the bad head bolt threads in this block, we're going to go ahead and get started on machine work. I'm going to start with decking this side here, get this down flush, get it cleaned up, and I also need to cut it to the proper height for the piston rod and crankshaft assembly we're going to put in here. So I'll probably start this, just kind of routine work here at this point, and I may put some color on here so that you folks can see a little bit better as it cleans up, but I'll probably kind of fast forward through most of this. And I also want to point out that I believe this engine is going to be for sale when we get done with it. It is a spare one that we had here in the shop. We're going to put together some parts and pieces that we have here and see if we can build an engine comparable to the one we're doing for the 67 Camaro. So let's get started. I just wanted to give you a quick little clip of what 4/1000ths did for the deck surface on this block. You can see on my Z-axis 4/1000ths, and it is completely clean, including where we did the thread repair. Things are looking good. Now we just need to go down whatever additional amount I need here to get our quench height right. All right, so we've got this first side surfaced. It's cleaned up over this insert we put in. I think there's plenty of meat there to seal the gasket, or maybe not plenty of meat, but enough meat there to seal the gasket. I want to chamfer some of these bolt holes and dowel pin holes now that it's been surfaced. The distance I took this down to should give us 40 to 45 thousandths quench height if everything comes out right, and we won't know that really till we start a test assembly on this, because connecting rods have been resized, and I'm going to size them again, so they may end up being a little bit on the short side. We might have to come back, take some more off, but anyway, let's clean these up. There, that looks good. So I need to change to the boring spindle instead of the surfacing head. That takes just a couple minutes here. And we are following up with another 350 right after just having done a 350. So all of the stops on this machine should pretty well be set to where we can just run through without having to make a lot of changes. That always makes things a lot easier. There is a little variation from one 350 casting number to another. Oops. But the two blocks we're doing, I believe, are relatively close, so there should not be too much here to worry about. Put my centering fingers in. I'm going to go down about midway on the cylinder. Going to zero my X and Y on the DRO so I know where I'm starting from. And this block we're going to make 30 over to match that used set of old TRW pistons. So I've readjusted my cutter to that size. And hand feed down just to make sure it looks like we're cutting the right amount. It does appear that way. So there we go. I'm going to start my vacuum over here. Little air filter that helps catch some of the black iron dust from when you're boring a block. So let's fast forward through that now. So while that block is boring, I want to show you what I'm working on over here. I have our 11-to-1 compression TRW pistons out of that Camaro motor, them and the rods that I want to be able to salvage here if we can. I didn't feel like they were good enough that I wanted to put them back in that Camaro engine again, but I do think they have some potential here. First thing we need to do is measure all of the skirts and make sure that none of them are collapsed or anything. These out of the box are intended to have about 4/1000 minimum clearance. So I want to see if these measure up that way. That one there, first one I measured will have about 4.5. That one would have 5. This one measures, would have about 4.5. About 5 there. About 5. About 4.5. 4.5. Strong 5. That one's just a little bit smaller. So I think we can make those work. Okay, my block has finished boring that cylinder. So let's go back to this machine and move over to the next cylinder. Put my centering fingers in. X-axis, we should move approximately 4.4 inches. Let's see how close that is. Actually, 3.99 inch and 1/1000 in the Y-axis. So it is relatively close to blueprint. And the first thing I'm going to do is cut the chamfer on the top of the cylinder. Whoops, wrong button. Feed down to 4.990 on the Z-axis. There we are. Change over to this other cutter bit that will bore the cylinder for us. Okay, there we go. So now back to what I'm doing here on the pistons and rods. I have already clamped these rods in our connecting rod vise and torqued the caps back on again so I can measure the big ends here. So let's go over here to the rod machine, and if I remember right, I still have this set up from some other rods I was working on. Let's see how round and on size they are. These should be right around 0 on this gauge, if they're the correct size. Okay, that one would be acceptable in the up and down in this direction, but it's a little bit wide on the sides, not too bad. It would probably be fine. Next one is real wide on the sides. Not too bad in this direction. 2.2247 is the tight side of spec. 7. So yeah, 0 is the tight side of spec. Want to make sure. Again, we're quite wide on the sides. Pretty close on that direction, maybe a little bit tight. Pretty close there. That one's kind of out of round. Gets real wide on the sides, tight in that direction. That's probably one of our best ones yet. That one's real nice. That one's not bad. A little bit wide on the sides. So a little bit of touch up on these rods and they would certainly be more than acceptable, but I think I can make them better if I actually resize the big end. So we'll go through, take the caps back off, cut the cap, a few thousandths, torque it back on, and let's see if we can hone these and make them a little bit better than what they are. Not that they're bad, but they can be better. So over here on our block, we're up out of that cylinder, so we need to move over to the last one. That one is actually 5 thousandths too far apart from the one we just left off on, and 1,000 or 1.5 thousandths to the side. Does it make any difference? No. That is so close. We're not going to try to correct for that or anything, because the crankshaft will correct for anything in this direction. Your wrist pin and the piston can correct front to back. Makes no difference at all on an engine like this. In fact, it might get us in trouble trying to correct for that. We might not be able to clean the bore up at 30 over. So let's cut that top chamfer on the cylinder. Take that sharp edge off, and that way the piston rings will go in just a little bit easier. Okay, there's our 4.990. Let's bring that up out of there. Switch to the cutter that will actually bore the cylinder and send her through. Now that this bank is all finished, let's roll this block over and bore and deck the opposite side. Take the triangle out, vacuum up some of the chips. We'll slip the triangle back in here. And I always check it with the level, not because I'm trying to make it level, because we are fixturing off of the pan rails, but it's just a little assurance that I don't have something way off when we do this. So let's drop down in here and find center on that first cylinder. So the first thing is cut the chamfer on the top of the cylinder. And I should be able to go to that same depth on my DRO as we did on the other side, which was 4.990. Boring bit in, and away we go. So we now have all of the cylinders rough bored to 30 over, and we need to switch over to the surfacing head, and we'll cut the deck down on this side to match what we did on the other side. So we'll bring the carousel around, settle that head, the boring head down on the carousel, remove the last nut, raise the machine head up, put the cover on, and spin this around. I guess it kind of went the wrong way, to the surfacing head, lowering down, lining up the studs into the head as we go. Have it snug down, and we are ready to go again. Spin this around so the cutter is facing this way. Disengage the down feed, take the lock, snap it into place there while removing it from the Y-axis feed. Get myself a little piece of paper here to go between the cutter and the top of the block so I can find my 0 point a little easier. There we are. So that should get us within about 3 thousandths. So let's take, I think we can probably go about 5 thousandths this first cut. Let's see, actually you folks like me to have a little color on there so you can see that better. So let me put just a little on here so you can see what it looks like after that first time across. And away we go. So while that is surfacing, let's move over here and you can watch what I'm doing on my rods. Remember, I had those torqued down and checked them, and they were probably not as round as I would like them to be. They were okay, but could be better. So in checking that one, that's actually a pretty good one there. Let's pick another one. And there you can see it really spreads out at the sides. Let's see if we can bring those sides in just a little bit. So to do that, we're going to go over here to the cap grinder, and I'll take this cap back off the rod. Here we have these performance bolts. They fit pretty snug. And I'm going to grind a little bit off the parting line here. I'm not going to go to the trouble to take the bolts out of the rods. These have already been machined the last time these were done. So I'm only going to do the cap side this time around. I'm going to take 2 small cuts and then an angle cut. So I'll place a feeler gauge under one side of that cap, grind to only one side of the rod or the cap. I'll spin it halfway around, feeler gauge under the opposite side, grind it, then I'll take it over here to the belt sander, put just a little chamfer I don't know if you can see that, but I put just a tiny little chamfer on these edges, and that way it breaks the sharpness off, so when I put the bearing in, when I slip it down in, it won't scrape the backside of the bearing and pull any metal off. So I'm blowing that off real well, getting the cuttings out of the way, back on again, clamped in the vise. That vise helps to align the cap to the rod, simulates being in the engine. We'll torque it to 50 pounds. And now let's go back over here and let's see what we did to the shape of that rod. So now you can see the sides have pulled in, probably, they're still going to be right at the parting line. It may be a little bit wide, but has really drawn the sides in, and we're not terribly out of round. I'm going to have about 2 thousandths to hone out of that rod to make it round again. So now we'll move on to the next one. You can see it has a spot in there, really widens out next to the parting lines. Not too bad in this area. Rod would probably be fine, but I know I can make it better. So back over here to the cap grinder, and we'll repeat this process. One straight cut, 2 straight cuts, angle cut that side, let it spark out, flip the cap around, angle cut the other. I'll take it around here to the belt sander to relieve that sharp edge. Blow the cuttings off. Cap back on the rod. And see if that did what we wanted it to do. And it did. It brought those sides in real nice, left me between 2 and 3 thousandths to hone back out of that rod. And in doing that, it'll become all but perfectly round. This block has just about made its way across the surfacer. Let's see what that's going to look like. Okay, that's pretty well done cutting. Maybe touching a little bit there yet, but not too much. Okay, surface of that block completely cleaned up, with the exception of this corner where I stopped it a little bit early. It was just barely cutting across there. We'll clean that up on the next pass. So I need to get the gauge out and measure where we're at. Based upon my DRO, I'm going to say we probably have about 4 or 5 thousandths to go. But this is the next day from when I first started on this block, so I'm not going to trust that my DRO is still set as closely as I would like it to be. So I want to measure rather than just depend on it. And I know this is on the wrong side. You can't see what I'm doing. You're going to have to trust me. But I am reading that we need right at 5 thousandths additional to be where we need to be. So let me feed this down another, I'm going to go down another 3 thousandths and then measure again where we are and then finish off from there. So I take this on down 3 more and we'll come back after it's made this pass and measure one more time. Okay, we've made our pass across here going to shut the machine off, and I'm going to hand the camera off to Alicia. That's Nicholas's big sister. And she happened to be walking through the shop. She does the bookkeeping for us. And I said, hey, come hold this. So that's what she's going to do. So I back this up, and she can talk.
I can, huh?
Yes, they may not hear her real well. Let me give her a microphone.
I don't need a mic.
Yeah, let me tuck a microphone in your shirt here. There you go. So now you're one of us.
Great.
Okay, if you kind of come in on this, you can see that it has completely cleaned, even up in this area here where I had not let the machine travel all the way to the last time. And I keep telling you people that when I measure this deck height on here, actually let's roll this the other way. And if you'll step around on my left side here, Alicia, just for the sake of showing this. And we don't have real good light on this side, but maybe it'll be fine. So when I put this across here, you have to find the low spot down in the main and the low spot on top, and I'm shooting to come out at 0. What am I, within 1/1000ths?
Looks like it.
Looks like about 1 mark of being at 0.
Yeah.
Well, that's what I was anticipating. So now we'll make a 1/1000th finish cut across the top of that block, and that work will all be done then.
Nice.
We can put it over into the hone, put the torque plates on, and start honing to get our proper clearance for those TRW pistons we're putting in there. And I couldn't remember for sure, but I thought yesterday when I finished off, I was at 9/1000ths on the DRO here. And sure enough, that's where I'm coming out today again. So let me drop down to 9. Like about there. And turn our traverse on. Make sure we're at 90 here. Full speed on the spindle of the cutter. And away we go. So a few minutes here, we'll be done, and I'll come back and we'll measure one more time, make sure.
And that's it.
And that's that. We've made that last pass I was talking about there. And checking here with the gauge, I would say we're about as close to 0 as 0 can be, wouldn't you say?
Yeah.
And by the way, that's Nicholas this time, not Alicia, in case you wonder about her voice. But yeah, we're there. So everything's done on this. I'm probably going to take countersink bit and countersink chamfer the top edge of the bolt holes on this, and it'll be ready to go to the hone. All done. Okay, as I said, the last step is to put a little chamfer on the top of some of these head bolt holes. Sometimes after you surface the block, it leaves a pretty sharp edge there with the top thread exposed. There we are, it's done. Okay, so we've run through all those rods, and I think I have them to finish size, but I want to double check my gauge here. So the small side of spec on the big end of a 350 Chevy rod is 2.2247 to 2252 is the bigger side, and I want to make sure this gauge is set at exactly the smaller side on 0. So anywhere from the 0 to 5 marks, 5/10ths of an inch, is considered acceptable. I usually try to keep them a little bit on the tighter side, but let's run through the ones we've done here and double check, make sure they're where we want them to be. And yeah, we're between 1 and 2/10 into the range. Same way with that one. Check both sides here, make sure we don't have any taper or anything going on. But you can see here, remember before we did these, how they jumped way wide on the sides and some of them kind of tight. But now I've got these to where out here on the side, for the most part, I mean, I do have one little spot right at the parting line where they get wide. But everywhere else, we are well within the acceptable range. We'll get 2 more of them here to check. I mean, right at the parting line, we jump out there a little bit, but then as soon as we get past that, we're in the range that is considered acceptable. That one really doesn't bump out at all. It's just within, what, probably a 1/10 of an inch of being perfectly round and in range. Same way there, I can see the needle jump when I go across the parting line, but it's right in the range of where it should be. Bumps out just a little bit out right at the parting line, but then comes right back in, as it should. And our last 2. Just all but perfectly round. Just hardly any movement in that needle. Same way there. I'm very pleased with where those are at. And let me see if I can get a shot here of the inside of it. You can see there, it is honed, cleaned up all the way around. There's just a little bit of a shadow right there at the parting line, which will not make one bit of difference. 100% better than they were before, and I didn't even consider them to be that bad before I started, but we did make an improvement. So that's what it's all about. So that completes my rods for this engine. In fact, it completes the week. It's Friday afternoon. I'm ready for a break. I'm going to farm all weekend, and let me turn this around maybe so you can see me here. I'm not sure if I'm in focus here or not, but we'll try. Anyway, as I was saying, this completes the week. I'm tired of the machine work. It's time for a little break from it. I'm going to go out and farm this weekend, work down my field, and get ready to plant some triticale next week. So we'll see you next week.